if I could give one message to every single amputee in the world, that would be it. Like, just, hang on, we're going to get to you. We're going to find you. We're going to sort you out. That's it. We will be there, and we are going to stick arms on you and turn you into something awesome.
Good afternoon, everyone, and welcome to another episode of the Design Exchange podcast. I'm your host, Thomas Grové, and with me today is Rafael Masters, which, forgive me for saying this, but the thing that comes into my mind is a mashup of the Teenage Mutant Ninja Turtles and Street Fighter, like Ken Masters from Street Fighter.
Okay, I've heard the Turtle one before. The Street Fighter one, I've got to say that's new. Generally, I get comments about Spike from Buffy, played by James Masters, or comments on the hilarity of the surname. I mean, I have an MBA, so both of my brothers also have got master's degrees. So, yeah, there are a lot of awkward family jokes.
It's like Masters.
Well, my younger brother's got a double MBA, the little sod. So he's Alexander Masters. It's... Yes, we have quite a collection going on.
Good. I'm happy that we started off with the comedy. I hope it sets a tone for the rest of the interview. Okay, today's interview is the first time that I'm interviewing someone who I've never met in person prior to the interview. Right?
Yep, no meetings at all, just the occasional Facebook chat.
Pleased to meet you in person, finally.
And you too.
Because you guys are working on such interesting things, I just want to go straight into it. Rafael has a company called Vulcan, I'm going to mess this up, Augmetics.
Correct.
You kind of want to say like Augmetics or something, but it's Augmetics.
We do get that. We get the occasional spelling mistake from people who are not familiar with the company. But yeah, it's a pastiche of a word, augment and prosthetic. So we just remove the N. It sounds a lot nicer that way.
Yeah, it's a nice sounding word. It's just like when I see it, somehow like Augmetics comes to my mind, but it's not. It's Augmetics. Yeah. And your company kind of has like a mission statement, which I think is brilliant. Let's see if I can recall this correctly. But it's to provide affordable, upgradable, and modular prosthetics.
Yes, in essence. The actual tagline of the company is building people, because that is very, very literally what we do. The goal is that everyone who comes in contact with the company, regardless of what their situation is, whether they're someone we're helping as an amputee or whether they're one of our staff members or just someone we encounter at some of the events we go to, they should go away having gained something and having improved themselves from that experience. And that's the essence of what we do with our technology as well. We chose the word augmetics quite specifically because prosthetics, the root for that is to replace, it's a facsimile. But augmetics, the root for that is augment, to upgrade, to improve. And that's also our sort of approach to the technology we do. It shouldn't be trying to fix people. That kind of lacks ambition. If you're going to be putting technology on people, we should be upgrading them.
Well, that's fantastic. I think when I first met you, because I saw your profile picture and it was clear there was like this robotic arm around your face, this metallic arm.
Yeah, the Facebook one where I'm going like this with one of our old prototypes. Yeah, that one's around the corner actually.
And it's hard not to click in, at least for me, because I've got a strong interest in futurism, post-humanism, cyberpunk, technology in general.
Oh, so you watched Alita then?
I did, yeah.
And Chappie, most likely.
Yes, I did.
And maybe you did. I think it's quite likely. The original RoboCop in the 80s?
Yes, I was a kid at the time.
Yeah, that's one of the reasons that we're here today.
Because you were inspired by RoboCop.
Well, with RoboCop, it was, there's a fantastic scene where he's just woken up and he goes to the shooting range and all the police are there looking at him and he just sort of stands there doing nothing. And then his leg opens up and the gun comes out into his hand and he shoots, puts it down, and it's just absorbed back into his leg. And that was one of the coolest things I'd ever seen. and sort of growing up and you saw all these prosthetics that are basically metal tubes, and you think there's so much space around it, there's so much more technology they could be putting in. The first time I saw someone with a real prosthetic leg, I was thinking like, why don't they have something that, comes out of there? Why haven't they stuck more technology on there if they have the space?
Right.
And that's, one of the reasons that we have the design approach that we do as well.
So if we were to look at human limbs, at the core, you've got bones, and then surrounding that, the majority of the mass is muscle and fatty tissue and connective tissue, right? And if you were making robot arms, you could use cables, presumably?
You can. A lot of it is condensed down. So you can use cables, or you can use things like stepper motors or servos or whatever. It depends how you want to transmit the power. But the prosthetic hands are never going to be, at this stage at least, they're not going to be as strong or as efficient or as effective as human hands. Like, your hands are absolutely incredible. There are like 27 bones in here. You've got thousands of nerve endings and connections. You've got hundreds of degrees of motion, and it's incredibly sensitive. We have way more than 6 senses. We've got, pressure sense, heat sensitivity. You've got your body awareness, all of that in this amazing bit of evolved organic gear. And you simply can't copy that with a prosthetic. But what you can do is take the basic movements and condense the things you need to do that all the way down. So you've got a very thin metal skeleton and a lot more space to put on extras and attachments.
So I assume you're not putting gun holsters in people's legs at this point.
At this point, no. That's when it comes to accessories and attachments. Right now, we're focusing more on things that help people do jobs, because one of the biggest issues with prosthetics in developing countries is you can give people prosthetics all day. You can give them $1 million prosthetic, but if they don't have the income to maintain it, then it's not going to see any use beyond the first year or so. It's even the simplest robotic prosthetic. You do need to take care of it. You do need to maintain it. It's constantly moving. It's taking lots of weight. It's a complex bit of kit. And so we design attachments that specifically help people get the income they need to sustain their prosthetic.
So I don't know much about prosthetics, but from the few news stories I've seen over the last few years, you always hear something like prosthetics can be prohibitively expensive.
Yeah, that's putting it mildly. So where we are, our prosthetic retails at about $1,000. The nearest competitor to what we do, like the nearest robotic functional arm, it has, okay, so to talk about our product, we have 3 different grips. So you've got your bottle grip, you've got a pinch grip, and you've got a key grip, which is done by moving the thumb. And it's all done from a single motor. The nearest competitor to us just has the simple bottle grip. It costs $2,500 compared to our $1,000. It's not modular. It depends very much on going to the clinic to fix any problems. The control system uses myoelectrics, which are a lot more challenging to calibrate and use longer term. So it's an inferior product, but it's a lot more expensive. And if you start moving up to high-end ones, there are some really incredible guys out there. People like B-Bionics and Ottobock. It's actually the same company now. Ottobock bought B-Bionics, but they do amazing hands. I mean, it's German engineering, So you've got like full individual actuated finger movement. You've got motorized thumb movement. You've even got lateral finger movement, which is absolutely incredible to engineer into a hand. But the prices start from about $12,000 and go up to $67,000 or even $100,000, depending on what accessories you want to get. And for people in developing countries, they don't really need the full lateral movement. They just need something that's affordable, that's practical for them, and that lets them take care of themselves and derive income. So it's a more complex equation than just having an expensive product. It's got to be a product that is affordable and practical for the user.
So is your target market then developing countries?
Our target market is everyone, actually. So initially, our business model is what we call freemium hardware. So the core basic model is about $1,000. Once you've got that, because the whole thing is modular, over time you can buy accessories, upgrades, attachments. You'll start off with an arm that costs $1,000, and within 5 years you'll be walking around with one that costs more than your car. So we will be moving up into the premium market later on, but at the moment the way it works is there are 38 million amputees in developing countries who have no access to care. There are about 2 million that do, but 95% of them have got nothing. In the West, you've got between 10 to 15 million amputees, quite likely lower than that, but they have their own healthcare system over there. So in the West, you can afford these expensive prosthetic products because you have the insurance companies, you have the healthcare providers, you have the governments that providing universal healthcare. And what that means is they can access more expensive products, but the system is far less transparent. And in the developing world, you have a much greater need for transparency because people are buying directly. There's no support system, no universal healthcare, nothing like that. So it needs to be something that is way more cost effective at this stage. And because of the way it operates, you do not have the larger companies in the West like Osur, Ottobock, Filauer. They make incredible technology, but it's far too expensive for where we are. They could probably engineer to this level and get it more affordable, but then that damages their existing markets. So there are no real options for people here. So our target is the blue ocean market of developing countries. We'll take that first. We'll use it to build up our base of these 38 million people with the core basic product. And then once they've got the product, once they're earning income, they will upgrade over time. And then as we develop the premium models, we'll then go over into the US, into the EU, and we'll take those markets too.
What are some of the design or engineering concerns when trying to make something like a augmentation or prosthetic more affordable?
There are quite a few. So the mechanical engineering always ends up being a lot more complex than you think. Specifically, when you're trying to do the more complex motion you try and do, the more of a challenge it is. So our current model, all 4 fingers here are attached together and they just open and close as one because that's the basic grip that people need. But if you're going to start doing things like individual finger movement, then you've immediately increased the number of motors by 4. You've increased the amount of wiring by 4. You've increased the size of the circuit board you need, probably by about 2 times in terms of the actual extra sockets, wiring, and connectors you need to put on. The microchips and processing, that's not so difficult, but just all of the connections are more of a challenge, especially because each part of the product we make is self-contained. So everything you need to operate the hand, except for the battery, is contained in the hand. Other companies like Open Bionics, or in fact, quite a few of the other non-3D printed ones, some of the Filauer and Osur models, they will have the motors, servos, and controls further down the hand. And that means they've got a lot more space to work with. But because we want to make it modular and design it so that if someone has a problem with their hands, they shouldn't be coming to us and traveling 5 hours and then waiting another 10 hours at the clinic. And what we do is we just stick a hand in a box and we send it straight to them. And because it's modular and designed for the user, they take off their broken hand, they attach on the new hand, they get on with their day. But engineering a product to the stage where it is that level of plug and play, and where it can be dealt with by the user, and where the technology is at a level where people in developing countries can make some of their own fixes locally, that's pretty complex. We could do lots of the high-end engineering and try and make individually actuated fingers. We've already done that, but just the sheer amount of engineering and maintenance required means that it's not the best product for people in developing nations right now. Later on it will be. But yeah, it's just compacting and making everything modular is one of the hardest things to do.
What kind of modularity are you really targeting here?
Well, there are a few different ways we approach this. So the first one is modularity from the viewpoint of maintenance. So all of the different components of the hand are self-contained, and the actual socket and arm, we've designed it so that there are no real points of failure within that part. That's the part that it is the most difficult for us to replace. That is the part that does require them coming into the clinic. So we've tried to put as much of the electronics and as much of the small, finicky, complicated parts in modules that can be removed and changed instantly. And the way we operate, we have a small stack of inventory in each province and one tech guy. And instead of him going to the users or them coming to him, we just ship parts. So designing it so that it can be easily maintained and all points of failure are replaceable, that's one of the approaches. The other one is for appearance. So once you've got this basic core model, all of the accessories and covers. So you know, if you want to change the color or change the look, change the style, maybe extend it a bit or make it thinner. All of those are things that are much easier to do once you have a standard design. At the moment, a lot of prosthetics are custom sized to each user, and we're aiming instead to go for standardization. So once you've got the core product, you can go on the website and find a whole range of extras that you know will work for your product. And because we know all of the shapes, in essence, it means that our cost to produce that and get it to them is a lot lower. There are other companies out there that make covers and accessories, but because each one is a custom job, their costs are really high, and that gets passed on to the consumer. But if you give them a standard template, then they can immediately drop their costs. We can offer them a marketplace, a platform where they can sell their products. And so again, everyone's a winner. They sell more product, our users get access to all these accessories a hell of a lot cheaper, and we increase our product range at zero cost. So that's another one for just appearance and accessorizing. The final one is we design special attachments for jobs. So even if I give you like $100,000 prosthetic, there are some jobs, really basic jobs, that you cannot do. The primary example that we use is a waiter. So to be a waiter, I can give you that $100,000 hand, and you have to carry a tray. So you've either got to try and balance this tray on your inorganic hand where you have no feeling, and then pick up things and put them on it, or you balance your tray on your organic hand, and then you're trying to pick up wet, dirty, disgusting plates with your $100,000 prosthetic. So it doesn't matter how much money I put into giving you that tool, it's still not going to be good enough for you to do the most basic entry-level blue-collar job. So what we do is, because our design is modular, we design special tools that do not look like hands. They have a very different form factor, and they just take off their hands, put on their attachment, and now they can go into work and do that job. We work with local corporations, and they sponsor development of these attachments so that we can put amputees into their workforce. Because it's, as I said before, there's no point giving them these tools if they can't maintain them. There's no point giving someone anything that's only going to work for a few months, and then, you know, it's just taken away because it stops working.
Is there any collaboration with occupational therapists when it comes to...
Well, we work with prosthetics experts and clinics, but in Vietnam, there are not really that many occupational therapists around. The people who really are in the industry here are the guys that provide the prosthetics, i.e. the clinicians, and some of their NGOs that work with people with disabilities to help them re-enter the workforce. There's not really very much in the way of professional physiotherapy, occupational therapy, even counseling. There's almost none of that, which is another thing that we have to do. We have to build our own, not just market support system or product support system, but you also have to build a mental support system, because it's a journey. Once these people have lost their arm, then generally there'll be a 1 to 2 year period where they're basically, not physically, but mentally, they feel broken and lost, and they don't know what to do. And that takes time to get them through that. And there are not many resources to help them do that in Vietnam. There are definitely not many examples out there of amputees living a full and thorough life with a prosthetic and integrating back into society. So that's another thing that we actually have to make ourselves.
Let's look at the customer journey for a newly amputated adult, let's say, and they get introduced to you guys, and either through a grant or through their own savings, they are able to purchase the entry-level prosthetic augmetic, yeah. The entry-level augmetic, augmetic,
Right, correct.
and what's going to happen to them? Like, is there training involved? Like, how much handholding do you guys do before they're just...
Quite a bit, actually. That's not really so much part of the process. It's just because that's how we've evolved as a company. Like we're still early stage. We need to talk to these people. We need to really understand their needs and make sure that we're meeting those needs. So the user journey at the moment is they'll have their accident, and then they'll have their sort of the period where they acclimatize to it and decide what their next step is going to be. Generally, either they will contact us, or sometimes we get family members who contact us on their behalf. They will then come in for a discussion, and then we'll organize a fitting. So they'll come in and get the socket made by our prosthetics expert, and then we fit the arm to them. They have a brief training session. We'll help them learn the controls of the arm, give them a few tests and everyday tasks to talk them through that. And then we'll do checkups for the first couple of months. We'll give them a weekly call. And then after that, it's generally up to them. We're setting up an online platform to make it a lot easier for them to contact us, and so that they can give us instant feedback. The hand is also Bluetooth equipped so that they can connect to their phone and they can send us diagnostics and information if they want to. And also they'll be able to get readings and learn more about their own arm. But at the moment, it's fairly intensive in terms of how we communicate with them. Longer term, when we scale that up, a lot of it is going to have to be digitized. We're going to have to find a way to offer them these same services through online providers. But yeah, at this stage, it's very, very personal.
Okay, you mentioned earlier that you have kind of a free sizing where one of the reasons you can keep your costs down is because you have some standard sizes. But I imagine everybody's arms a different thickness, everybody's point of amputation is at a different position. So how do you actually have standard sizes?
There are a range of ways that we do that. The first one is, to explain how the system works at the moment. Most of the sockets, the part where people are still directly connecting to the arm, that is still done by professional prostheticists. And that is what most of the industry does. Where we get slightly different is all of our hands are standard sizes, the locks and connectors, the batteries, the charging docks, and actually the arm as well, because we 3D print the arms out of TPU. It's fairly strong, but it also has a bit of flexibility to it. It's a silicone-based plastic. And that means that once you've got the socket, which is quite a hard thermoplastic, you can put the arm on it and then just put in 2 screws and it will attach to that socket. And one of the advantages of designing everything to be self-contained is all of this is space. So it doesn't matter if they have a short stump or a very long stump. All of the electronics and all of the equipment can still be mounted around that.
Okay.
So there are 2 main options. For the short stump people, the socket will go to about here, and then we 3D print the arm on top, and that gets attached. For people with a long stump, then the entire arm is got the hard thermoplastic covering, and we just connect the hand on, put the battery on the outside, and give them a cover. So it's still got the same set of components, the same basic sort of hand and control system, just this arm part changes slightly. Longer term, we need to get more data from people, but once we've served enough users, we'll have a very good idea of what are the standard sizes for people's arms in Vietnam. What would be a good average width to print at, and that's when we can really scale up and start producing with injection molding. The other thing that we're looking to do, not yet, but probably in the next year or 2, is we want to design sockets that require 0 outside assistance. So we want adjustable sockets. The idea being eventually that you'll be able to go online, tell them like where your amputation is, and we will be able to send you the entire package that you can completely fit at home. So you'll take it out the box, you'll put it on your arm, you'll make a few twists and adjustments, and that'll be fitted. We can't really completely take the experts out because there are things like pressure points and understanding the biology behind it where you still should have some expert medical input. But for a lot of it, we want to make it as adjustable, as adaptable, and as flexible to the human body as possible.
I was wondering, like, to what extent you might have flexible pieces that you clamp down after the fact to.
That's kind of how the arm operates now. It's designed so that there are two sort of ears that go either side, and then you put the socket inside and you just screw it down where the ears are. Later on, for adjustable sockets, that's what we're going to be doing. Flexible components, probably a vulcanized rubber of some sort, and then we'll use a BOA device, so you just rotate it a bit and that will draw it tighter. And you have like 4 or 5 of them down the arm, so you have different areas where you can change the pressure to make it more comfortable.
Okay, here's just like a newbie question about the functionality of prosthetics, but I've seen systems where just by kind of tweaking your shoulder girdle, it causes tension that makes things collapse. And then I've also seen systems where you're measuring the electroactivity of the nervous system and using those impulses to drive action. What kind of things are you guys doing?
Okay, so that's the mechanical versus electric divide. We do the electric route. We don't do mechanical prosthetics. They do have distinct advantages and disadvantages. So the disadvantages for mechanical prosthetics are they depend on other body movements, and you have to apply real pressure. So people will have to stretch their arm out to open or close it. And you will, of course, have to wear more straps and support hardware for that. So it takes a lot more time to get into. The significant advantage of those, however, is for at least for the lower level, like anywhere up to a really high-end prosthetic, until you reach like the $60,000 point, a mechanical prosthetic will actually give you better feedback because it's your own body that's controlling the motion as opposed to servo motors, and you can sometimes feel the resistance depending on the design. So there are some distinct advantages there, but on the other hand, it's a lot of awkward body movement, a lot of straps, and you generally don't get really nice looking prosthetics for that. The ones you were talking about, the ones that read muscle impulses. So there are a few different versions of that. The one you were talking about is myosensors. So those will go on your skin and follow the impulses underneath. There are, again, advantages and disadvantages. The advantages are, of course, you use the old existing muscles and it can look a lot more natural. The disadvantages are cost. They're quite expensive. Calibration. They take a lot of time to learn. Durability. They can be fairly fragile. Practicality. So for a lot of people, if you've been an amputee for a very long time, or if you lost your arm in an industrial accident where electricity was involved, you're not going to have the same nerve endings. You won't have the same muscles that are left over. So that's not a practical option there. For us, we decided that the best option, especially to do remote servicing, we put the controls in their toes. So the hand links up to an insole, and underneath your big toe and your mid toe or little toes, you've got 2 buttons, and you just use that. Press a button and it'll open, press a button and it'll close. And that's much more cheaper, it's more robust, but it also allows people some subtlety because people can't tell how you're controlling it. So it can still look very, very natural, and there's no calibration. You just press the button and it goes. 2-minute learning curve. With myosensors, it takes a lot of time for it to learn and to figure out the sensitivity, and there can be like a reaction delay. It can take time for you really focus, and then the arm will close, and this just cuts all that out and makes it a lot quicker.
Well, I'm pleasantly surprised that your solution is neither of the two I knew about. It's like a third way altogether. That's fantastic.
Well, once we've got that, so the buttons are in the insole. There's a little flash drive that clips onto your ankle. Eventually, we can probably engineer it down to put the whole thing in the insole. But one of the other things that lets us do is, like, the human body has a fantastic range of movement. We can stick buttons on you anywhere. If we've got that flash drive transmitter, we can just stick 2 buttons on that, and you can have them like inside your elbow, so you can open and close like this. You can have it on your neck, so you've got a little twitch to do it. It's quite a flexible
Put
system.
on the roof of my mouth.
You could, if we could,
drive it with my tongue.
once we've made that waterproof. Well, no, that's something that we have also considered. There are all kinds of ways to do this. It just depends on how open people are to mounting technology on their bodies.
Okay, I'm extremely open to mounting technology on my body, but are there cultural differences in Vietnam that would make someone less likely?
Yes. They're the same cultural differences you'll find all over the world. It basically comes down to conservatism, I guess. People in developing nations haven't been exposed to the same media that people in developed nations have. And they haven't been shown that this is possible. You know, when they do see it, it looks very far away. It looks very distant. It doesn't feel real. And so, yeah, they're a bit more wary of it. There tends to be like, oh, what's the catch? The other one is, as they're quite conservative and haven't been exposed to the same media and tropes, specifically sci-fi, a lot of the older generation prefer a prosthetic that is more concealed. So they'll like prefer the latex skin that makes it look like a human hand. Whereas the younger generation who have, they've grown up seeing Marvel films and they're used to playing video games where the guy who has the robotic body, that's the guy that's stronger and tougher and faster. That's an upgrade. They have that trope in mind already. And that's actually really important to be able to appeal to. People have to be able to have seen this image elsewhere and see people respond positively to that. And we're slowly getting there with the media exposure we're getting here. But that's also something that we have to work on quite a lot as a company. And that's why we focus a lot on publicity. It can seem a bit shallow at times, I guess, but we really welcome all the publicity we get, most specifically because we want to show amputees out there that this is available for them. It's possible for them. There are clear paths for them to get to have this technology. And yeah, it's something that they can have. And it's something that people will respond positively to.
Are you providing both solutions, like synthetic skin ones and more mechanical looking ones?
Yeah, our product is designed to have both. The arm is a little bit more of a challenge because it's simply larger, and wrapping it up in latex skin is a bit more challenging, especially with heat. You're going to get hotter. But we've recently slimlined down one of our designs so that we can now fit latex skin over the whole thing. So people do still have that option. But a lot of the younger amputees we've spoken to, they like the more high-tech sort of robotic look. As long as it's sleek and follows the human form factor and looks like sort of a cooler version of the human hand, they are quite happy with that, especially when they see the huge amount of positivity that comes towards our main tester, Dirk. Every time he's out with the arm, people are always coming up and they're fascinated by it. And it's a bit funny for me because I know where we've come from, I know where we're going, and I know what my expectations are for the end product. And so when I see the product that Dirk is wearing now, like, I think, yeah, that's pretty cool, but it's still sort of high school level stage. We really need to step up our game and make it look as sexy as something you'd see in Marvel. But the response that we get from everyone around us is, wow, this is an incredibly awesome, fantastic, high-tech bit of kit. It looks, finished and done and amazing. And so there's a bit of a disconnect for me there because I'm always going to be convinced that we can still do that a little bit better. But the response that we already get for the technology and the look that we already have is, overwhelmingly positive. And that's something that we want to show as much as we can.
I would be more drawn towards the robotic arm versus the I don't know what you would call it, android arm. If for nothing else, because I think you would avoid the uncanny valley. I have a feeling that a latex skin wrapped or silicone skin wrapped prosthetic would somehow, like from a distance, you'd be like, is that real, or what? Something feels off about it.
Yeah, but a lot of the older people, especially, it partly comes from a place of fear. Like even that is better than being marked out as obviously broken. And that's the key thing. A lot of these people, they still see themselves as broken, and they know that society sees them as broken. And we need to be able to change that. And so they see a prosthetic as that upgrade instead of a band-aid, because that's what they look at it as right now. And you're right. You do have the uncanny issue where it sort of looks similar and alien at the same time. And that's why we're really trying to encourage this, if you've got it, flaunt it. You've got this incredibly fantastic, expensive, amazing bit of kit on your arm. And it's very, very high tech. It's something that people should be looking at and admiring and be jealous of. And if you've got that technology and you're going to use it anyway, show it off. Let people see how awesome your stuff is. And it just takes time for them to get there. And it takes a lot of showing them examples. And the older generation are just less likely to go for that.
Have you built an iPhone into any of them?
That is on the list. One of the first things we considered was phone charging. I mean, we've all got phones, we've all got chargers. I'm a firm believer that power should be transmittable from any device to any device. I mean, we now have phones with wireless charging. So if you've got a phone and I've got a phone, we don't even need cables. We can just switch power between them. We should have the same thing for prosthetic hands. You should be able to charge your hand from your power bank. You should be able to charge your hand from your phone. You should be able to charge your phone from your hand if you really want. And that is, so any way we can find to make the technology more universal, more practical, and easier for the user, we're always interested in that.
So what's the journey of your company been so far? And
challenging?
Yeah, like how long have you been doing this, and what's your background?
We've been doing this for about 2 years. My background is a weird one. I'm not an engineer in any way, shape, or form. I just happen to grow up with a lot of sci-fi, a lot of Lego, and grew up about 200 yards from the biggest disabled college in the UK. So most of my friends through my teenage years were in wheelchairs, very reliant on technology. And it was a fairly special place, actually. They lived very full lives. And for me, a key part of that was they weren't patronized. They were treated exactly the same as everyone else. Like, the village looked out for them, but for example, they'd all go down to the pub and they get absolutely hammered. And you wouldn't have they're disabled, we shouldn't let them get wasted, it might be bad for them. It was, they're kids, they're going to get, they're teenagers, they're going to get wasted. And so, have your beer, get hammered, and then, you'd see these long conga lines of wheelchairs sort of winding their way back home. Because the one in front would be in the powered wheelchair that cost about 30 grand, and they really souped up those chairs. And then you'd have like 5 or 6 behind on their manual wheelchairs, just hanging on. So you have this, wheelchair snakes, drunken wheelchair snakes making their way back home. And, I'd get phone calls at 2 a.m. from my mate, like, "Oh, Raf, come help me. I've fallen in a ditch and I can't see Andy and I can't get up." So I'd be wandering around the village at 2 a.m. looking for a pair of wheels sticking out of shrubs in the side of the road. And so I grew up with an awareness of they're people, same as everyone else. The only thing that really matters is what's in here. Everyone has a brain. Everyone has one that functions, and that's all that you really need to generate value and to have worth, so to speak. And anything else we can fix with technology. So once you've given people these tools, any of them can create that kind of value. And coming here and seeing amputees and people who were disabled and the way that they do not get the same opportunities, there's nothing wrong with them. If you give them the right tool, then they can go and do this job as well as anybody else. Like, their minds are perfectly fine. And if you look at the West, we have way more white collar work than blue collar work. And that it's all about what's in here. Developed countries don't have that quite yet, but they will. And so, I've always had an awareness that you just need technology for us all to be on basically the same playing field. And you don't need to do that in a patronizing way, because you can have people with this technology who are actually better, upgraded more so than baseline humans.
You've seen there was controversy like 10 years ago with a runner with blade legs that was
Oscar Pistorius, I think it was, and they complained that they were running faster than the people with organic legs.
Yep.
And that's pretty much where it should be as well. Like people, when we talk about the Paralympics, as far as I'm concerned, that should be the Cyborg Olympics. That should end up really pushing the limit as opposed to, the regular Olympics, which is just, this is what we can do with what we've got. The Paralympics should be, okay, what can we do that's extra?
Yeah. It'd be fun to see some form of professional competitive sports that were pro drugs, pro performance enhancing drugs.
Yeah, what is the furthest to which we can push humanity?
Yeah.
And in that case, the measure is not the individual performing so much as the technology and the basis and the philosophy behind them.
I guess F1's kind of like that.
Yeah, it is.
Some way, yeah.
It absolutely is. And that I genuinely think that is the kind of approach that I would like to at some stage see. So yeah, that's so I grew up with that kind of experience. And the other thing that I've been aware of, I moved to Vietnam about 10 years ago, and over the last 10 years, I've seen the maker scene grow. We've seen the advent of 3D printing. We've seen the advent of much smaller, compact CNC machines like this thing behind me. And there's a lot more that you can put in a workshop and a lot more that you can make. We've seen things like Raspberry Pi and Arduino emerge. And with all of that technology out there, we've got high school kids who are making prosthetics for a few $100s, and they're not at the product level, but they're certainly workable. And so when you see that, it just makes me really angry and frustrated, actually, that there was this real problem out there. All of these people who, they're missing parts there. It's not a nice way to say it, but they are basically broken. And there is the technology available to take that problem away. There's the technology available to make them upgraded and better than everyone else. And it's not even that expensive to do, but no one was doing it. And so, yeah, that was just, incredibly frustrating. And fine, if no one else is going to do this, then I guess we have to. I mean, there are 100 other problems and issues that also get me mad, but I'll start on this one. We'll build it up, get a few billion in the bank, and then we'll move to the next one and fix that too.
This is fantastic.
Yeah, sorry, I kind of segued into the mad visionary bit there.
No, but that's like I'm always following the exploits of Elon Musk, and
Actually, that's well, he's not the greatest example to pick. He can be a bit of a wild card at times. But in terms of someone who looks at the impact they want to have and knows that impact will generate profit later on, like things like SpaceX, things like Tesla, that wasn't about we can make a ton of money. Well, obviously they will in the end, because it's an inevitable trend moving towards electric cars where you can transfer power wirelessly instead of with gasoline and pumps. Like, that's a no-brainer. SpaceX having reusable, more efficient rockets and, humankind moving off planet. Again, that's absolutely inevitable. But the way he did it, it was all about that dream and that vision and that social change and the inevitability of money following that.
I think it's interesting how you say these things are inevitable and no-brainers, whereas there's probably a significant portion of the world who, to whom it's not inevitable. I mean, within their perception, it's not something that's a no-brainer. It's not something that's inevitable. There is let's just take one example, like the conventional automobile, gasoline-powered automobile. That whole industry is kicking in, had been kicking and screaming and avoiding change for as long as possible, not embracing it. So I don't, and if they had really thought this is inevitable, this is where it's definitely going to go, they would have jumped on it. They would have done it.
That's one of the things that has puzzled me for a while. For at least 15 years or so, I've been wondering, why aren't the big oil companies buying up every renewable energy company they can find? Like, they own the energy now. Why are they not looking to future-proof themselves? It was inevitable, as we've seen. Renewables are growing. Who is going to say no to free energy? And that free energy, you cannot turn fossil fuels into a free energy. It doesn't matter what your economics are. It's a finite resource, and you have to go and dig it up, and you're constantly moving around to get new things. That's not sustainable in the long term in any way, shape, or form. Maybe we can move to biofuels, but again, that's just another way of saying renewables. We're creating an organic thing that grows and processing it. So for me, whether they see it or not, just in terms of base economics and efficiency, it's gonna happen. Like for robotic body parts, same. As far as I'm concerned, within 50 years, it's going to get to the stage where, you'll be 90 years old, you'll have rheumatoid arthritis, maybe the gene therapy won't be working, and the doc's going to say, okay, time to switch over. Same for like anything organic, our bodies are going to deteriorate. I genuinely think we're not going to get a practical longevity solution anytime soon. But the notion that we can transfer our minds over and digitize that's something that people are already looking into. That's something that we were talking about in sci-fi 30, 40, 50 years ago. And it's in the process of happening. I mean, everything from my childhood has come true. Like, I watched Star Trek when I was younger. And, when I was 9 or 10 years old, I'd see them walking around the deck of the Enterprise, and they'd have these paper-thin computers, and they just poke and prod them and be like, yes, Captain, the Tribbles are here. We need to beam down or whatever. And that was the coolest thing in the world. I've got 3 of them at home right now. I've got a couple of iPads. I've got an Asus pad. I've got that already. Robotic hands. Again, that was something that we were actually dreaming about as little as 60 years ago, and now we've got them. We've got, full lateral movement. These trends are things that are fairly easy to see if you look for where the money is, look for how things are going to be more efficient, and look at what people want and dream about. These things they just make sense.
Even the most recent example. Now, to be fair, this episode won't be edited for probably 4 months or something after the recording, because I got such a backlog. But so when I say like, this recent news, it will be very not recent anymore. But I think something like the Cybertruck definitely, a person's reaction to it shows you where they are in that curve. If they're the kind of person who was watching Star Trek as a kid and being, that's some dope technology, that's exciting, I want a piece of that in my life, like to fetishize about futurism and then just to make it happen, even though it bucks convention.
Okay. I think I should clarify here. I love technology, but not for technology's sake. So I'm also a massive fan of classic cars.
Okay. So do you hate the Cybertruck?
In terms of the look, the roof. I'm sorry, but the roof of the Tesla Cybertruck is one of the ugliest things I've ever seen. The entire concept of the truck itself, I absolutely love. I think it's incredibly awesome. But I am also, as much as I love technology, I am very, very wary of us becoming over-reliant on it. I'm a big believer in flexibility and adaptation, and that humans should be able to comprehend the systems they rely on. So anything where you've really over-engineered and you don't have people around who are able to understand that actually causes me concern. When we talk about automatically driving cars, or cars where all of the controls are electronic, and you've got power steering and it's not like actually connected, it's fly by wire. That kind of thing genuinely worries me, because I like to have fallbacks. I like to have a practical mechanical redundancy. So I'm certainly not in favor of fetishizing technology for technology's sake. It's much more about what is the most efficient and intelligent way to use this technology. So for our approach, we could have tried to go the full electronics way and go with independent motors for everything, but that's not the most efficient use. It might be, the most clever use. It might be the most futuristic or high-tech use, but it's not right for the needs of what people have now. And so that's also, I think, a very clear balancing factor that needs to be taken into consideration. So absolutely huge fan of the Cybertruck. Hate the roof, but love the general concept. I'm just a bit wary of any vehicle where you can't step in if there's a problem.
Right. As far as the roof goes, it bothers me that there's not that it's not trapezoidal, that it's like a triangle instead of a trapezoid. I just kind of wish there was a little bit of a flat section
That
at
is
the top,
exactly my issue with it. I don't get the pointiness. It just
yeah.
it
Even
bugs
then,
me.
they show like overlays of the shape of the truck with a airfoil and like for aerodynamic efficiency, and you're like, and they always say, look how aerodynamic it is. It's almost the same as an airfoil, and I'm like, and if you just made that one bit flat across the top, it would be the shape of an airfoil. So why not just go that extra step? But
People will be cutting that roof off in no time. You're going to find custom models, I'm willing to bet.
I wonder if it would retain its structural integrity if you do that,
Oh, God, that's a good question.
because it's an exoskeleton. So, like, I don't know.
Oh, that's a discussion for another day. We'll have
Yeah.
to ask Elon.
Okay, call him up.
Well, tweet him. He tends to be quite responsive if you say the right thing.
Yeah. Well, I imagine if you're tweeting from like some kind of Vulcan Augmetics account, that it would raise an eyebrow. Are you guys on social media?
We're on social media, yes. We're on Facebook. I think we have an Instagram. We have a Twitter somewhere, but we don't use it that much. Main reason being we're in Vietnam. And social media here is pretty much like Facebook and Zalo. If we were based in the US, we'd probably be a lot more active on Twitter and no doubt picking a lot more fights. But I'm quite happy that we're just nice and fluffy on Facebook.
It's curious that Facebook is the predominant social media in Vietnam, and it was the one that was banned for a long time. And
It's never been banned here. They have at times tried to block it or talked about blocking it. The last time they did that was a couple of years ago, and all it really meant is a whole new generation of Vietnamese learned about proxies and VPNs.
right.
It hasn't done a lot. You just change the DNS number and that's it. You're through.
They when I first moved here, it was not maybe not banned in such that if you were on it, you'd go to jail. Not like that kind of. It wasn't forbidden, but all the telecoms were required to not allow access, and you would have to use your own name DNS to access it.
That was fine. Everyone just switched to Google's DNS and Facebook carried on and the government sort of quietly let it drop.
But I wonder if the forbiddenness of it is what caused it to be the most popular.
Quite likely, yeah. As soon as people like to be difficult, people like to be contrary. So as soon as you have a government telling people you can't do this, you can bet your bottom dollar that there are going to be a million people ready to stick their middle finger up and say, oh, yes, I will.
The forbidden fruit is the most delicious. So you've been around for 2 years. A lot of the people I talked to this week, they said that the first 2 years were the hardest, and they're happy they didn't give up, because now it's been 8 years, and so. But you're at that 2 year mark. So are you?
No, I'm still very much loving what we're doing. We're just getting started. Bearing in mind that we're in medtech, so the development cycles tend to be a bit longer. But even when we compare ourselves to our most direct competition, so there are other companies out there that are doing, well, people assume it's similar. So they also make prosthetics, and most of our competitors, their main focus is let's make affordable prosthetics that look like the human hand with 3D printing. That's generally, those are the three things that you'll see. For them, they tend to have much longer development cycles than we do. So I tend to use these guys as an example a lot. I feel a bit bad for shooting them down because they do amazing work. But there's a company called Unlimited Tomorrow in the US. And they started out with over $1 million of funding. They had help from Microsoft Labs. And it took them 4 years to fit their first product to a user. And that user was a girl called Momo. And in the 3 weeks before she flew over for the fitting, they basically had to steal Microsoft's entire hardware engineering division to complete the product in time. And that was to fit their first person after 4 years with over $1 million of funding. And it's going to take them 6 years to go into market. They estimate they'll be in the market next year. So compare that to Vulcan. We have had Well, we've spent roughly $60,000 over 2 years. We've gone through 9 iterations. We've fitted 5 people. We've designed 3 separate modules or attachments to help people get into work. We've designed 2 different control systems. We've taken pre-orders for 25 units. And we're going to be in the market in about 2.5 years. So
From now.
No. In about half a year from now.
Half a year from now.
So it's taken our nearest competitor about 6 years to get to market. We're going to do it in 2.5 for less than 1/10 of the cost. And we've managed to fit 5 times the number of people in... Actually, we fitted our first person after our first year. So it took us 1/4 of a time to fit 4 times the people. So we're doing... Yeah, compared to our competitors, we move really, really fast. We're just about ready to really start growing and scaling. So yeah, nowhere close to giving up. The biggest challenge by far has been investment, actually. Doing medical hardware and doing prosthetics in Southeast Asia, it's a challenge. Investors here are more conservative, and it's rather complex because we're a social enterprise, we're a technology company, and longer term, our plan scales way beyond simple prosthetic arms. So you've got to find that balance between telling them what is your viable business plan right now and what is your crazy plan, long-term vision for the future that's got loads of money behind it where they make a profit. And how does that balance with you being a social enterprise and having social impact? So if we were in the Valley, if we were in San Francisco, yeah, we'd be rolling in money by now. But being where we are, we've had to be a lot more careful and lean, and it's a challenge to get investors to share that mad vision.
Do you find that this more lean approach has the lack of overabundance of financial resources been beneficial in any way?
It certainly, actually, I think it has. I mean, I love efficiency in that way. It's enabled us to make a product that is a lot cheaper. It's enabled us to do it with a much smaller team, and it's also just been something that we've had to do because we've started almost entirely with founders' capital. Still, hunting around for the next round of investment, and that's also why we've decided to go for more organic growth. So we're already bidding for corporate projects, and we're already working with the UNDP to try and be their main prosthetic supplier on some of their mine clearance projects. But yeah, the lean approach has helped, but there are times where, we have a range of asks. The most practical one that we use around here is $250,000. And we get 2 responses to that. We ask for 250, which is the bare minimum we need for organic growth. And then we get the response, that's an okay amount, but we can't put that much in without revenue. Or we ask for that much and people say, oh, why so little? You should be asking for millions of dollars. And, if we were in San Francisco, that's what we'd be asking and that's what we'd be getting. But yeah, in Vietnam, in Southeast Asia, it's much harder, especially when you are doing hardware in Vietnam, you're medical hardware in Vietnam, and you're a social enterprise. And I think one of the big challenges as well for investors that they haven't quite cottoned onto is social enterprise doesn't mean NGO, it doesn't mean nonprofit, it doesn't mean charity. It simply means you are a company that is aware and seeks to control the impact they have on society. Every company in the world is a social enterprise, whether they like it or not. They do have that impact. The only question is, are they aware of it or not? Are they controlling that or not? And in the next 10 years, being sustainable, being a social enterprise, it's not going to be something that's added value. It's going to be the default. Millennials and Generation Z, we are conscious consumers. We care about how the companies that we buy products from do business. And we are aware of the buying power that we have. So being a social enterprise, investors, conservative investors, are still looking at this as, oh, that means there's no money there. What it actually means is this is the default that you need to be making money in the next decade. The next decade, we're going to see environmental concerns and social concerns rise to the forefront of what consumers look for. And I think that is something that they are much more aware of in the West than they are over here. Over here, you have a huge grassroots movement, actually, and that's really, really positive. Like, the consumers here absolutely know what they're talking about, but that hasn't gone to the sort of more stratified, moneyed layers yet. And yeah, in the West, you've got billions of dollars being poured into sustainability initiatives because they see that there's money there. And in the East, we haven't quite got to that stage. They will eventually. I think the economic trends are going to necessitate it for them, but not quite there yet.
One thing I can't help but notice in Vietnam is how buildings tend to deteriorate quickly. You know, you see a new building, and within a year, it looks very weathered. And when we made our office, like, we repainted it after the first year because it already needed to be repainted. So, is there, when it comes to durability of the augmetics you're crafting, what kind of material choices do you have to consider is there anything, like, environmentally about this climate that makes it harder to?
Yeah, it's generally not material choices, it's design choices. So, for example, the foot sensor control, that's a design choice because it's something that's more practical for developing countries. It's more robust. You can actually make it waterproof. It can deal with the weather better. It can last longer, and it's easier to replace and doesn't require calibration. So that's one design choice. Another one is by making the whole thing modular. We know that these things are going to break. We know every prosthetic breaks. The only question is, how quickly can you fix that problem? How quickly can you deal with that break? So again, that's why they're modular, and we just do inventory in each province, and it gets shipped out and the user can replace it. It's why, instead of trying to follow the B-Bionics model of engineering every single movement in and having 15 motors, we just try and do it with one servo and use very clever mechanical engineering to maximize the movement. So we have actually considered that quite a lot. It's one of the reasons why our design philosophy and approach is so different from what people are doing in the West.
Going to the foot sensor, which doesn't have to be a foot sensor, could be placed anywhere, but I'm curious, like, is it a toggle or a shift? Like, do I have to keep it held down to make it closed, and as soon as it's released, it opens? Or does it toggle it between one or the other?
Up to you. The whole thing connects to Bluetooth, so you choose. You know, open your phone, like, I would like one button to mean this. I would like one button to mean this. You just tell the hand how to process that information.
Okay. And are the hand positions binary, or are they analog?
Binary, pretty much. It's open or closed, and if it's closed, like, it has some range of movement, but you're still, like, applying pressure. And for the 3 switches between key grip, pinch grip, and bottle grip, that's manually done by the user. It clicks across.
Okay, that's clever.
We've motorized it before, but you just end up putting in more and more and more things to support each other, and it ends up being a much heavier and less durable product.
I mean, it's because if it was, if it's got, I don't know the mechanical terms for this, but, like, there's I don't know how to say it, but, like, for instance, the dial on the top of my camera, it's not free floating. It's kind of like you turn it and then it locks into a fixed position, and then you turn it again and it locks into the next position.
So that's just a ball bearing lock.
A ball bearing lock. There we go.
Well, that's what we call them. I'm not sure if that's even the engineering term. Bear in mind that the engineers are Vietnamese and I'm not. So we just find whatever
you have, like,
language
a
works
spring
between
on
us.
the back of a ball bearing?
Yeah, that's exactly it. You have one part will have a small recess, and the other side will have a ball bearing coming up and a spring underneath, and you just click, click, click around.
So, like, the pressure of turning it pushes the spring down.
Yep.
And then
you can also just do a quick twist, and you can lock that in place as well. And we've done that for the wrist, and we've done that for the thumb.
Let's see. Yeah, because it seems like even without the benefit of your other arm, you could still push it against your leg or against a table surface to change its position.
And that's what a lot of users will do, and we actually design around things like that. We are very well aware you cannot make a perfect human hand for a reasonable price point, and it is a waste of energy to try, because whatever you do, for amputees most of the amputees we deal with are single amputees. So they've still got one working organic hand, and we are not going to be able to replace that. Like, as I said, it's incredible. Human hands are phenomenal bits of evolution, and we can't replace that. So what we'll generally have is your organic hand is for fine control and fine detail maneuvers, and your artificial or inorganic hand, whatever you want to call it, is for gross control. So for most actions that we do, we will hold the thing and manipulate the thing.
Oh, right.
And so we design the prosthetic hand to hold the thing. We know that we can't replace this. So in another play on words, it's designed to augment this existing hand.
Are there any people with two
double amputees? There are, and that's a much more challenging proposition for us. It is one that we're nonetheless looking into. Part of the challenge is those are actually people with a much more real need, because if someone's a double amputee, they're basically stuck at home and they need a family member to take care of them permanently. And I find it very hard to imagine anything less dignified for people than to be lacking both of their arms. Just taking care of yourself, getting dressed, basic hygiene, it's incredibly humiliating for them. So that's something that we actually are looking into. But one of the things that you have to consider there is they have to put this stuff on in the morning, and they have to be able to make adjustments to one arm with the other arm. So you end up having to think of very carefully, what movement are these people going to have that's purely organic that they can control, and how can we connect that? So if they want to take out the hand, they don't have enough fine control to like remove the battery. So we need to design a battery switch that you can just use the other hand in a very, very blunt way. So it's a slightly different and more complex design approach. It's something we're working on, but there are lower numbers of those. So we're looking to get the broadest product out there first, and then everything else we can build on top of that.
Oh. I have a friend in Rwanda who lost both of his hands. If things ever, align themselves, it'd be fun to introduce you to him.
Oh yeah, if we're still here by the time you put this video out, just tell him, hold on, we're coming. I mean, that is, if I could give one message to every single amputee in the world, that would be it. Like, just, hang on, we're going to get to you. We're going to find you. We're going to sort you out. That's it. And if he's sitting there in Rwanda right now, fine. Give us 3 years, man. Just hang on until then. Just exist, survive, whatever. Do what you gotta. We will be there, and we are going to stick arms on you and turn you into something awesome.
That's awesome. Well, Rafael, thank you for taking the time to talk with us today and share about your adventure in creating the $1 Million Man.
Yeah, much more affordably as well.
The Million Dong Man.
Yeah, that works. That actually pretty much works. Yeah.
We have the technology to make him stronger, faster. If people would like to find out more about you, they can go to wearevulcan.com.
Yep. They can find us on wearevulcan.com. You can look up Vulcan Augmetics on Facebook. You can find us on LinkedIn. You can probably find us on Instagram or Twitter, and we'll be delightfully surprised if people message us on Twitter, because that never happens. Yeah, or you can just hunt me down on social networks as well. I'm always quite happy to
found him on Facebook,
chat.
so
Yeah, Facebook, I'm quite easy to find. I'm the guy with the robot hand doing that.
Thank you very much.